Back to my YouTube channel, and today it is day 14 of 100 days problem solving challenge. And today's problem statement is of LeetCode, that is mid level, and it is asked in most of the companies: Google, Amazon, Microsoft. So this problem statement is maximum subarray. We have a given array and we have to find the maximum subarray with the largest sum, and we have to return that sum. Suppose if we have a given array -2 this, and in this 6 is the maximum largest sum, that is continuous, means 4 minus 1 2, that is in sequence. This sequence is giving the maximum sub array sum. Fine. If one element, then we have to return one element. So in this video we will first see the brute force approach, and then we will try to optimize with the famous algorithm, Kadane's algorithm, and at the end we will solve in a LeetCode this problem. Fine. So let's start with the brute force approach. We have a given array and the output is 6 for this maximum subarray sum, 4 minus 1 and 2. So what is the brute force approach? Brute force approach, we will try all the possible, means we will try to find all the sum, and which sum it is giving the maximum, we will try to get a track of maximum sum in maximum variable. Fine. So in this we will use two loops. First is outer loop and the second one is inner loop. That outer loop will start the index I and inner loop will end the index. Fine. Means from here to here we will find the sum, then from here to here we will find the sum, then from here to here we will find the sum. So at the end we will have a track of maximum subarray sum, and whichever it is giving, we will at the end we will return. If none of that is a maximum subarray sum, we will return the main value, means we will return minus infinity or anything 0 minus 1 as per the given question. So like this will you not understand. I will this like maintain a running from sum from I to j, and we have to update the maximum sum. Fine. So here we are using two loops, so it will be time complexity will be n square and space complexity n, because we are checking all the possible subarray with the two nested loop. Fine. So let's start the coding in a VS Code. So here we have a given main method. In that we have array and we have a method that will pass that array, and in this sub method we will write our business logic, means actual implementation of that. So first we will find the length of that array, nums of length. Fine. And then we will have a one max sum that will have a maximum sum. By default we are going to give the integer dot main value, and we will store it is showing sonar issue, nothing, no problem. We will return max sum. Fine. Now we will write the main logic. The main logic is we will try all the possible sum by using two loop. The first will be outer loop. So first we will write the outer loop, int I equal to 0, I is less than equal to n, I plus plus. Now inner loop. So here like each time we will calculate the sum, so that one index, that is each time it should be like initialized with a 0 in starting position. Like if I'm calculating the sum whole, then I updated my maximum sum, but my current sum I have to make 0 again to have this record, means next sum, and then we will check that next sum is greater than maximum or not. If it is greater, then we will update. Then again from here we will try to find the sum. So each term we have to make our sum 0. So here what we will do, here we will make current sum equal to 0. So here we are making the current sum equal to 0. Now again we will try to find all that sum. Int j is equal to I, j is less than till n, j plus plus. Fine. So here we are calculating the current sum is equal to nums of I, sorry, j. So here we are calculating the current sum, and in that we will check whether our current sum is greater than max sum or not. If the current sum is greater than max sum, so in that case we have to update our max sum is equal to current sum. So here this is almost done. So what we are doing, we are trying to find the possible of all the sum of the subarray, and we have a maximum sum that will have a track of maximum subarray sum. So first we found all that sum and we store in a sum, and we will check if it is greater than maximum. So here it will try to find each time, like 1 2 2, whenever it is greater than, then it is update. So here the current sum will find the sum of all the subarray sum, and it will keep a track of maximum sum in max sum, and at the end we will return max sum. So here we are using nested loop, means two loop, first this loop and this loop. So it is n square. Now we are done. Now we will try to run this, whether it is giving the proper result 6 or not. So yes, we are getting the 6. That means this brute force approach is correct. So the problem here is it is taking time complexity n square. So we will have to optimize this, because if the drawback is, if our largest, means if our array is having large element, then at that time the system will slow down, system performance will slow down. So to overcome this, that Kadane's algorithm come in picture, that is optimize approach. So in this next we will use the optimize approach here. So almost this one, here till here we will remove here. Fine. Okay, this one is already we have a main method, and we have that sub method, and here we have declared the maximum sum and we are returning the maximum sum. So in this we will try to optimize that previous one only, that current sum and max sum. Fine. So we will write the Kadane. First we will see the approach of Kadane's algorithm. So what it says, instead of checking every subarray sum, we build the best subarray on the go. Means we will, instead of trying to all the possible, so we will check which is the best subarray. Means we have to start, either we will start and we will check whenever our current sum is going less than, it is going in negative. So as we know that negative element will never give largest subarray sum, so we will make that current that 0. Means if the current we will make the current sum is 0, because whenever it is going negative, it will decrease the value, it will not increase. So instead of taking that negative value, we will just reset our current sum is a 0. Fine. So first here what it says, steps, we will first current sum initialize a maximum same as that previous one, and for each element num in nums, add nums to current sum and update the maximum sum. That's it. And whenever our current sum is going negative, we have to make the current sum as a 0. So we have to clear that the current sum should always be like Kadane's algorithm. The step is clearly we have to declare the current sum, maximum sum, and then each time whenever our current sum is going to negative, then we have to reset is 0. Fine. So here is a walkthrough of that, like starting index -2. So as the current sum is 0 and maximum sum will update -2. Again the second number 1, so current sum we have taken 1 and maximum sum 1 is greater than -2, so we have to updated the maximum sum. Again the third element is -3, so in that case we are not taking that negative element, so we just make the current sum as 0, and in that case maximum sum -3 is not greater than 1, so it is 1 only. So the fourth element is 4 only, so in that case we are updating our current sum, that is 4. So in that case we have to update maximum sum 4, because earlier it was 1, so now updated as 4. So now fifth element is -1, again it is going -1, so we can minus because it is not going to the negative, so we have updated our current sum, that has become 3, but still the current sum is less than maximum sum, so maximum sum is as it is. Then 2, so we added 2 into 3 to 5, we updated the current sum, now it is greater than maximum, so we updated the maximum sum. So here we are, next element is 1, so 1 we added in, updated the current sum, that becomes 6, so our latest maximum sum is 6. Now again we counter -5, so if you minus that 6 minus 5, that will become 1, but as maximum sum is greater than current sum, the maximum sum is 6 only. Now 4 we added 5, that it is less, so at the end we got that 6 as the maximum subarray sum, that is giving 4 minus 1 2. So we will try to do the coding here. So here we will have a current sum equal to 0, and we will use here for each loop int num is equal to nums, and we will try to find the current sum. So and we will check the condition, if the current sum is greater than maximum sum, so we have to update our max sum as a current sum. Now one thing we notice, like whenever our current sum is going to negative, means if it is going to less than 0, at that time we make our current sum as a 0, means here so here in this case -3 is the current sum, so we make the current sum is 0 -3. So like that we will try to do the dry run of this. Here we already did, suppose the first element is -2, so here the -2 came, the current sum become -2, and as -2 is greater than -infinity, so maximum sum become -2. But when it came to here, as -2 is less than 0, so current sum become 0 only. So in next case 1, so now the current sum is 0, so 1 is added. Now 1 is greater than -2, so maximum sum is updated, so like that it will work. So this is giving, we are done with the n time complexity, and space complexity is 1 only. So if you will compare both, first one is taking n square and second one is taking n, and both are taking space complexity n. So that is Kadane's algorithm. So now we will try to solve in a LeetCode this problem same. So what we did, first we have taken current sum, that is 0, then we have taken the max sum, what will be the integer dot min value, and then we have used for each loop, you can use anything. And then what we have done, we have taken here current sum, if our current sum is greater than our max sum, so we are updating the max sum, and whenever our current sum is going negative, so we have to make current sum is equal to 0. This is the only implementation. Now here we can return maxsum. Fine, nothing we have to do, just now we will submit. All the test case pass. So we have completed this challenge. Thank you for watching this video. Please like and subscribe and do share with your friends.